Hello everyone, I am Nikhil. I am from Sri Venkateswara College of Engineering. I would like to explain the course of Automata Theory and Compiler Design, and its course code is 21CS51. Let's move on to the topic is compiler design and spaces. By understanding the basics of the compiler construction, introduction to compilers. A compiler is a sophisticated software tool that translates an high-level programming language like C, Java, or Python into the machine code. But the purpose is to bridge the gap between the human readable code and the machine executable code. For the importance is an introduction to compilers is for the efficient code translation enables the optimal utilization of the hardware resources and resulting in the faster and more reliable programs. Let's move on to the overview of the compiler design. The compiler design involves the multiple phases to ensure the accurate and optimized the code generation. The position in the software development life cycle, a compiler can transform the abstract code written by the developers into the executable instructions that understood by the computer's hardware. And the diagrams of the compiler that the compiler design can process with the flowchart and emphasizing the each of the phases enroll. The different phases of the compiler is the lexical analyzer, syntax analyzer, semantic analyzer, and the symbol table, and the intermediate code generator, the error handler, and the machine independent generator, and the machine independent code optimizer, and the code generator, and the machine dependent code optimizer. Let's move to the phases of the compiler. And first, we have more to the lexical analysis, and it is also called as a scanner. And the lexical analysis involves breaking the source code into the tokens. The role of the lexical analysis is recognizing the passwords, identifiers, and the letters and operators. And next, move on to the syntax analysis, and it is also called as a parser. And the syntax analysis that it checks the structural arrangement of the tokens in the code. And the role of the parser is to building a parse tree based on the grammar, ensuring the proper syntax. Let's move on to the third one. That one is a semantic analysis. The semantic analysis verifies the meaning and the correctness of the code. And the role of the semantic analyzer is detecting the logical errors and ensuring the proper variable usage. And the fourth one is the intermediate code generator. The intermediate code provides an abstraction that for simplifying the code translating process. And the role of the intermediate code is and the surveying and an intermediate between the representing that it's closer to the machine code. The next one is more to the fifth one, that is code optimization. The code optimization enhance the efficient and performance of the generated code. That the examples of the optimization techniques is the constant folding and the loop enrolling and inlining. And the next mode, the sixth one is the code generation. The code generation transforms the intermediate code into the machine code. And the role of the code generation is the producing the efficient and execution code to the target architecture. And the next one is the lexical analysis, and it is also called as a scanner. And the lexical analysis that involves the scanning of the source code to recognizing and categorize the lexemes. And the lexical analyzer identifies the tokens such as passwords, identifiers, constants, and operators. And examples for the lexical analysis is for the input int x is equals to 10, and the lexical analysis recognize then the tokens int comma x is equals to and 10. These are the lexical analysis that identifies the scanner by the tokens. And the syntax analysis, and it is also called as parser. And the syntax analysis ensures that the arrangement of the tokens follows the grammatical rules of the programming languages. And the parser constructs a parse the tree that represents the hierarchical structure of the code. And the example is displays a sample parser a tree for the basic architecture expression like A plus B star C. Let's move on to the semantic analysis. The semantic analysis checks the meaning and validity of the code. The semantic analyzer informs the type checking and ensures the proper usage of the variables. And examples of the semantic analysis is and detecting an error when trying to add a string and an integer. The next one is intermediate code generator. The intermediate code is an abstraction that represents the program's logic without focusing on special hardware details. The common intermediate code representation includes the tree address code and quadrupes. And the example for the intermediate code generator is for the displays of the snippet of the tree addresses code for the simple assignment statements. The next one is code optimization. Code optimization aims to improve the efficiency of the generated code, and the techniques includes the constant forwarding, loop optimization, and common sub expression eliminations. And the example is the show how the constant forwarding simplifies. That's the expression like 2 plus 3 plus or 5. That's during this optimization. Code generation and code optimization. The code generation is in final phase where the intermediate code is translated into the machine code. The code generator produces the efficient and executable code for the target architecture. In the final code optimization, the further enhance the performance, ensuring the best possible execution speed. And example for the code generator and code optimization is the compare the generated machines code and before and after the optimization for a special code snippet. Thank you for watching this video.